Welcome to our today's webinar and thank you for joining. Today we've got our colleague from EPAM, Bhawani Prasad, who is a delivery manager, and we will cover the quick and easy steps to explain smart contract architecture. And before we get started, just to let you know that if you have any questions, you can type them into the live chat in YouTube and we will bring them up during the presentation. And we will also have some time at the end. So now I would like to pass the mic to my colleague Bhavani. Please, the stage is yours.
Yeah, thank you all for joining. And my name is Bhawani Nandan Prasad, and I'm EPAM. So I'll start today quick and easy steps to create a smart contract in blockchain. So so let me share my screen. I hope my slide is visible. So blockchain quick and easy steps to explain a smart contract architecture. So here most of you know aware of blockchain. What is blockchain? So I'll go through quickly a few concepts. So a blockchain is a peer-to-peer decentralized distributed ledger technology architecture where peers can communicate and validate transactions without depending on a centralized entity. This change from centralization to decentralization makes blockchain so valuable in the current scenario. If a user sends a digital currency or information to another user in the distributed ledger technology, which is called DLT, then the transaction will be added to the block. The block basically contains a lot of transactions, is then verified against the consensus methods chosen by the blockchain network. So blockchain, we can say, is system of recording informations in a way that makes it difficult or impossible to change, hack or cheat the system. Each block in the chain contains a number of transactions. Every time a new transaction occurs on the blockchain, a record of that transaction is added to the every participant's ledger. So the agenda, I'll walk through the smart contract. What is a smart contract first, and then traditional contracts by a smart contract, a smart contract life cycle workflow, a smart contract architecture, benefits of a smart contract, a sample Solidity a smart contract layout, example Solidity smart contract a structure for bank KYC, and some references how to create a smart contract. So here a smart contract, what it means. So a smart contract is self-enforced digital versions of traditional physical contracts between two parties. And blockchain a smart contract, what is difference between blockchain, a smart contract platform upon blockchain network with digital transaction protocols having contract terms and specifies a predetermined set of rules around the contract. So blockchain smart contract is totally digital transactions protocol based. Is a smart contract legal? Yes. Most of the countries or regions it is legal since not all agreements must be in writing to be considered legally enforceable. A smart or self-executing contracts would be proper and valid under contract laws in various jurisdictions. Traditional contracts and a smart contract. Traditional contracts usually having parties and then their physical contract paper mostly paperwork, and there has been third party involved to execute the uh, contract and having negotiations and follow up. But in a smart contract it is self executing between parties and execution. There is no third party. So a smart contract is more secure, autonomous, and no third party middleman, and it is very trustworthy. Key benefits of a smart contract is as it is foundation, no middleman. It is a cost saving and code is law. Every rules is temper proof. It is already coded and it cannot be modified during the execution. It has default backups, avoid manual errors, and trustless execution means it can be executed with full trust, autonomous execution. So this facilitates business process and transactions across the borders, even with unknown clients. Facilitates business to enhance their online systems security. Facilitates to in-time killings, expensive and paper-based agreements. Facilitates business by acting as a digital enforcement agent. Facilitates to bring speed and transparency in business processes. It is self-verifying, self-executing, and tamper-proof. A smart contract functioning example, like there are two persons, one is buyer, another is seller, and there is asset which will be sold. So here the seller creates a smart contract for the transactions rules protocol based, and there is no third party. So this smart contract is coded in blockchain, and it is self execution and enforcement of contract when events are triggered. So if the terms and conditions are met between different buyers, it is sold out. If the term and conditions are not met, it keep cancelled for that party. Another example is for some transactions like money transactions. Like Tom wants to send money to Victor. Tom uses blockchain as a platform to execute the entire transaction. The transaction is recorded in the blockchain. Every party in the network is notified of the transaction. The transaction gets approved if everything is fine. While it is initialized, online transfer of money happens and Victor gets money. So this is the one example how blockchain works with for money transactions. So features of Ethereum. So basically, a smart contract is this which I am going to present is based on Ethereum right now. So it, a smart contract for Ethereum, it is automated programs that execute upon satisfying certain conditions. So it has a smart contract, it has currency, it has fast transactions, security, and community. So these are five features. Currency, mostly these are based on ethers and ERC20 tokens. There are various tokens, and for transaction currency related, we use ERC20. Mining speeds are very high and transactions are completed in 10 to 12 seconds. Security, it has and smart contracts are used to enhance security. Community, Ethereum has extensive developer community support. Ethereum ecosystem. Ethereum ecosystem consists of technologies that help enable decentralized browser and applications such as storage, dynamic communication, and distributed computations. So this Ethereum ecosystem has DApp. DApp is distributed applications which works on decentralized browser, and this browser and in the Ethereum ecosystem we have a storage which uses Swarm tools, and communication is mostly based on Whisper. Computation we can do by via Solidity or Julia or Viper. So I have given some will wonder what is difference between Bitcoin and Ether. So here a smart contract, Ethereum smart contract use Ether, and in the market from the beginning there are Bitcoin. So the main difference I have highlighted here is uses secure hash algorithm. Bitcoin uses secure hash algorithm which is SHA-256, but Ether use ETHAS algorithm. So algorithm is different, used as currency for purchasing goods and services. Ether is used as a currency and making decentralized apps. Bitcoin digital currency to compete against fiat currencies and gold. But Ether is mainly used for smart contracts. Bitcoin transaction speed is slower, but Ether transaction speed is very much faster. And Bitcoin very high mining price. If you transact on Bitcoin, it is a high mining price, but Ether has low gas prices comparatively. Then again, what is gas? So gas is a unit of measuring amount of computational power required to run a smart contract. or perform a transaction. It is similar to a transaction fee for every operation performed on Ethereum blockchain. So there is a gas limit. You can, when you define a smart contract, you can put gas limit, and gas limit is the maximum amount of gas that a user is willing to pay for performing an action or confirming a transaction. Gas price is the amount of ether that a user is willing to spend on each unit of gas. So how transaction fee is calculated? It is gas limit into gas price. A smart contract life cycle. A smart contract has flowing stages in its life cycle development. So first it starts with development, how we develop. So development and testing of smart contract using Solidity is the first page. You can use Solidity, Julia or Vapor. Another is once a smart contract is developed and saved, you can save as .sol. Then it is converted into AVI and bytecode. Compiler converts the smart contract code to its respective AVI and then into a bytecode. And then blockchain is deployed on the main network, test networks. You can test then main networks, and then contract execution happens on the main networks. So here a smart contract bytecode is stored on Ethereum virtual machines. EVM is a main component of this system which works on a node. So what is the layout, contract layout? So you can refer docs.soliditylang.org if you want to know details. But here it starts first with pragma. When you define a smart contract, the first line is pragma, solidity, and its version. So keyword to identify the version of solidity to ensure compiler compatibility. Next, it is a contract word is mandatory. So keyword that defines a smart contract codes like contract, you give contract name and some parameters variables. Third is the function. A function accepts a string parameter and stores it in the variable name. So public keyword is a visibility specifier. So here is function is just like defining your rules, protocols. S- Types of Ethereum wallets. So Ethereum wallets are mainly categorized into below types. So one is there are four kinds of one is web wallets which work on your web browsers like MetaMask, Mist. These are example. Then there are desktop wallet which is installed on your desktop like Bitcoin Core, Mist, Armor. Then we have mobile wallet which is more popular lightweight applications like Bitcoin or Mycelium. We have hardware wallets, Ledger and Trezor, most secure as they store keys in physical devices. These four types of Ethereum wallets are popular. Then one best term is decentralized application. Whatever you develop, it is called a decentralized application. So dApps are applications that run on a decentralized distributed peer-to-peer network and do not have a central authority controlling the application platform. Their codes are open source and all users can access them irrespective of the region they reside in. All dApps run on the blockchain network on top of smart contracts. So what is architecture of dApps and its framework? So it is primarily client server based, which runs on Ethereum nodes. So in client front end is called Web3, which interacts with a smart contract. We can develop client in React View, client side UI, or you can use wallet like MetaMask for and with private keys. Server is backend. So in server you can develop a smart contract using Remix ID or Truffle development framework. So other components are Ethereum nodes like Genasi. So when you develop, you can develop on local private networks. There are test nets where you can test your smart contracts, and then main networks where you can deploy and transact. So these are basic architecture for dApps. Another vanilla design I have. Vanilla design is a simple like set up a local Ethereum node and use JSON RPC interface for you of your application to do all kind of transactions. So here we have blockchain which broadcasting means application which submits transactions. You can query a state with private Ethereum node. you can sign transactions, you can unlock account. So all these are local infrastructure which communicates with the main distributed networks. Another is offline transaction signing, like your application has offline signing and using public nodes. So offline transactions, here you define your application using private key. So you have to use private key for signing of all offline transactions, and then you can submit transactions or query state to the blockchain. So here various steps between client and server and blockchain interface is: first you add event listener on the server side, then you have add filtered event listeners, you submit transactions from client, and then receive event on transaction performed on OX, and client get receive transaction received with events. Then again from server submit transaction that affects transaction, and receive transaction received from server, receive event from transaction performed by server. So these are basic steps for when you do offline transaction signing on public nodes. Tokens, these we discussed, ERC20 is very popular, and another tokens we have ERC721, ERC777, ERC1155, 2981. So ERC20 is the main interface of all implementation should conform to ERC20 metadata, like extended ERC20 interface, including the ERC name symbol. So this is primary tokens for all kind of means blockchain smart contracts for minting tokens, storage approvals, or token level support for flash loans, or support voting delegations, any kind of, this is fundamental we have to use. Ethereum networks. So here, as we mentioned, there are three kind of networks. Uh, Mainnet, which where it is deployed and we use cryptocurrency transactions. Test networks, where network mimics the main production kind of, but it is for developer to test. And private network, this can be implemented by changing the parameters of the Ethereum network according to the needs of the user to develop the smart contract. Test networks, these are example. You can use proof of work network, then you can use Ropes10. If you want to use proof of authority network, you can use Godly. If you want proof of authority network for open Ethereum clients, you can use Coven. If you want proof of authority network for Geth clients, you can use Rankby. So these are four options for test networks. Then we have Ganassi, which is local network. Ganassi is a lightweight replica of Ethereum blockchain, and it can be installed on any operating system and replicates the actual blockchain network. It is mainly used by developers for smart contract unit testing. Okay, Ethereum clients provide interface to become full nodes. They can then verify transactions, parse blockchain and smart contract data, and mine and create blocks. So here in this network, you see there is a system where blockchains are um, interacting, and the system interacts the client. So client interact with system, and then connect to blockchain networks. And there are another party. So left side we have one party, right side we have another party. Using the blockchain, they do the transactions for the such basic architecture. So types of Ethereum clients. So what kind of Ethereum clients we develop? So we develop either Go Ethereum or Parity. So Go Ethereum command line interface, it is a terminal based application which is used to perform the functions of a full node. And Parity is a graphical user interface, a visual interface that can be used as a web desktop application to perform full light node activity. Go Ethereum is a terminal-based Ethereum client implemented in Go language. It was developed by the Ethereum Foundation and provides a command line interface for exercising full node powers. Features of Geth: mine blocks and earn ether. You can mine block, you can earn ethers, perform transactions and transfer funds, validate transactions and interact with the smart contracts, update and maintain blockchain history. So all these four features you can have for Go Geth. Another you can how to connect to Geth. So um, there are commands like Geth. So Geth command to connect to main networks. So Geth allows you to connect to Ethereum mainnet, Rupest, any other main or test or private, any kind of. And command to connect to Rupest10 again Geth minus Rupest10 or Ringv. So it's very simple commands to you can connect. Then Geth data storage you can have on Linux, like this folder kind of the folder. Windows we have app data roaming Ethereum. Mac we have a library Ethereum. Okay, so the main is data dir parameters through which you can access your storage. Parity, so Parity is another lightweight fast multi-network Ethereum client written in the Rust language. This is one of the most commonly used third-party Ethereum clients. So features of Parity are uh, it's a clean modular code base for easy customization, minimal memory and storage footprint, synchronize the updated blockchain in a few hours as compared to a few days in other clients. So Parity is very fast. You can quickly deploy it. And how to connect the commands are also again very simple. Parity minus minus chain mainnet. So here we use chain. Parity data storage syntax are like this. So you can create in Linux home u.local share.io parity Ethereum, or Windows you start with app data, or Mac library application support. And it does synchronization. So again now is steps how to create your Ethereum smart contract. So in this sequence you can create and to get a successful smart contract with less compiler issues. So simple and coherent smart contract code. So that is refactoring. So first thing is because it is just like Java code. So you can have means refactoring is very useful here. So here you have to ensure that the contract in question solves individual problem, and this helps keep things simple and help avoid design and code errors. So when you do refactoring, again, it modularize the code to keep contracts and function smaller. So another step is keep only the necessary data in the smart contract necessary. So basically, this is tips techniques when you create smart contracts. So and I'll discuss steps in next slide. So but this is only tips. So here keep only necessary data in a smart contract. So blockchain should be used only for the parts of the system that require decentralization. Analyze the application data and separate them in onto on-chain or off-chain data. Design the state variables for the smart contract to be efficient storage for the on-chain data. You can leave the off-chain data to be managed for a higher level of applications, or you can use confidential information. Should not use if you have any confidential information. You use API. Don't use in the smart contract. So another is avoid gas costly patterns only for Ethereum. So if you using Ethereum, not like Hyperledger or anything. So for Ethereum, you should gas you avoid gas costly patterns because Ethereum is little costly. So the creator and user of under optimized smart contracts will always be overcharged during the deployment and running because they consume more gas than it is required. So fourth tips is expect and prepare for failures. So as it is rules like functions, there may be some issue vulnerabilities or some failures. So you need to be careful here. So inserting rules code to pause the contract whenever there is a observed deviations, like ERC20 helps here to pause the contract or other tokens. There should be a limit on how much money the contract is handling. So you should have limit there, gas limit. There should be provision for upgrade, bug fixes, or improvements. So design for re-entrancy attack calls for to untrusted contracts. So you have to take care of re-entrancy attack. So here re-entrancy means avoid any external calls when possible, as calls to untrusted contracts can introduce several unexpected reasons. So when you using any third party external calls, you be very careful here. Finish all internal work first. You do all internal blockchain rules protocol first, and then only you call external functions, not in mix, don't mix it. So design for denial of service, this is security things. Use pull over push for external calls, mostly use pull over push, and or a DDoS attack for short. This becomes more game as where payments are involved. So whenever there is a transaction payments, you use DDoS attack, security there. In such cases, it is advisable to create a pull or withdraw mechanism to obtain fund rather than pushing funds to the user. This will help circumventing your DDoS attack. Timestamps are imprecise on blockchain and can be influenced. So we have to be careful with timestamp, even with margin of seconds. So loopholes should not be created there during the execution of a smart contract. You know, we have appropriate data type selection. So data type is again important. You don't use mostly strings, or you have to use proper data types. So and you examine the data types to avoid any errors. And you can also use EVM 256 bit. So it is suited for integer computations. Whenever you use Ethereum 256-bit string, that is best suited for integer communications, and it is a dynamic sized variable in a smart contract. Appropriate, okay. Understand the visibility modifier for data. So visibility modifier is again a important here. Any variables on the blockchain is viewable to everybody, all irrespective of visibility modifier. So it should pay attention to the order of a statement, use secure hashing, okay, and use of access modifier is again very important in implementation of policies and rules. um, Separate system connected by APIs, like when you using in your blockchain application, messaging, emails, phone call, fax. So all these API you separate, don't mix up. Next, I have steps to develop Ethereum smart contract. So prior we discussed tips and techniques. Now it is steps. So steps, like first we need to create a wallet at MetaMask in private network. Next, you can select any test networks, add some dummy ethers to your wallet, define the smart contract agreement in its scope, consensus strategy, design it, use editor remix or a truthful, whichever, to code the business logic as the smart contract in Solidity. Step 5 is create Sol extension file, which is a smart contract is saved as .sol with ERC tokens. So we have to first create ERC tokens code and deploy and test a smart contract at test networks. So finally, after test, deploy Ethereum smart contracts at mainnet hosting DApp. So for this, you have to make your smart contract live, switch to the main Ethereum network at MetaMask, add some real ethers, Now try again. Deploy your smart contract using Remix. After successful deployment, visit Etherscan site, search your smart contract address and select. Then you verify it, copy your smart contract code and paste it at Etherscan. Having same compiler version should match. If you have used optimization to S, you if you had selected optimization in Remix during the coding, you use that. Otherwise, you can no. Again, you verify. So it will take a few seconds finally, and this smart contract will be deployed if you have no any errors at Etherscan. So I'm giving you one business case here for trade finance. Like so, how it happens normally without a smart contract, and how a smart contract makes it different. So as we see in traditional trade finance, the first step is we define the sale contract between buyer and seller. And once a sale contract is signed, we ask a bank to open lending of credit, you know, and then bank issue lend of credit, and then um, this lend of credit is sent avoided advice receipt of LC is sent to seller, and the seller check that LLC, and then again seller connects to the um, shipment. So shipment happens again. Shipment bill of lending transfers the check, and once bill of lending is verified between seller and buyers, then payment from bank buyer to seller happens in exchange of bill of lending, and finally, you know the payment to bank buyers to sellers happens, and then ship by the buyers happens, ship to buyers happens, and present bill of lending for goods, and buyers present the bill of lending for goods. In a smart contract, it is only lesser steps, and it is faster. And how it works here, first step is upon purchase, the agreement of sale between the importer and exporter, means buyer and seller, is shared with the import bank using a smart contract on the blockchain. So there are bank is involved. So in bank, then in real time, the import bank will have a capability to review purchase agreement, draft terms of credit, and submit obligations to pay to the export bank. So there is buyer, seller, import bank, and export bank. As a third step, the export bank will review the provided payment obligations, and once approved, a smart contract will be generated on the blockchain to cover terms and conditions and lock in obligations. So there is no paperwork, it all happens digitally within a few minutes. Next, after receiving the obligations, the exporter will digitally sign. So there is a signing there. How means who is selling the exporter, this digitally sign, and blockchain equivalent letter of credit digitally is created for initial shipment, and shipment initiated. So next in step 5, goods will is inspected by third parties if there is any auditor and custom agents in the exporting country, and their action will have to digital signature. So all signing here is digital, and during transit, goods will be transported from country A to country B. Upon delivery, importer will digitally acknowledge the receipt of goods and trigger payment. And finally, using provided acknowledgement, a smart contract will automate payment from importer to exporter via the smart contract. So this is the 8 steps for trade finance, and all things happens digitally, and signature is also all digital signature. One example I am saying here, blockchain smart contract for bank QIC. So traditionally, if you see in left side, we have various steps. For bank KYC, customer submits KYC document to the bank. Bank forwards KYC document to centralized intermediary. Intermediary stores data in centralized database. Other institutions seek intermediary for KYC data, causing KYC checks or data incurs cost for security of data. So this way KYC was happening, but here in decentralized blockchain, it takes very less time and it is faster. I can show you one code quickly in Remix. So Remix is a tool where we have smart contracts as example. So for KYC, so for KYC, if you see there is a contract is defined where who is admin is a type of address data type, customer structure is defined, customer username, their string hashing, and rating, and bank with which customer which bank belongs. And then bank structure is bank has ether address, and then there is a KYC request. So KYC request is a structure defined. So in the contract we have admin and the three parties, customer, bank, and KYC request. So this way we define contracts, and then we have mapping for the customers, mapping for banks, mapping for KYC request, and we use different functions in a smart contract. All the rules or transactions kind of will be as a functions. So it may be add KYC request or add banks, add customers, delete bank, verify anything. So all these rules we define in again back to the slides. So the remix which we show you, this is one of the editor, and we can refer its feature from remix.ethereum.org. So remix id has text editors and a special smart contract building features. So this is one development tool. It also provide browser based networks for testing and development and deploy. So it has, if you see, as we have, it has icon panel. All the important plugins are placed in this panel for the users to access immediately. We have site panel. The GUI for the various plugins is embedded. We have text editor, and we have this called terminal where you can see warnings or any error message. So this is a normal editor. Yeah. So here in Remix ID, the networks. So Remix can deploy a smart contract to its own JavaScript VM, Ethereum testname, or local blockchain network, or Ethereum mainnet. And we use for front in Web3. So Web3 has provided and injected Web3 and JavaScript VM. So Web3 provider helps to connect to local node such as Ganase or Geth using MetaMask. Injected Web3 helps you to connect to the Ethereum mainnet or a testnet. And JavaScript VM is inbuilt sandbox used for developers to test it. So this is the three networks, front-end networks. So how it happens here, users connect with web access, and through Web3 it connects to the Ethereum node, and Ethereum node connect to the blockchain. So steps to access a smart contract is simple. We have to install Web3 and create a new Web3 instance, then connect to the Ethereum blockchain network and connect to a smart contract using AVI, access the smart contract function. So we use Web3 Ether library, and it is very simple steps. This is how to install and create an instance, and you can connect to contracts. So you can define in application the contract, like a smart contract is created. Now you going to use in the your application. You can define contract. You can use contract address and function names. So if it is like serverless, you can also use serverless. Like you can deploy on any cloud versions and host a static page of Web3 enabled app to distribute client node to users on like AWS or Google Cloud or any cloud provider. Using, if you have Swarm or IPFS, and your client is using BZZ or IPFS protocol, you can deploy it on serverless. This technology is called canonical flavor. Okay, so how we do this is simple commands which I've listed here. So next we have reference. So if you want to learn the code for hands-on smart contract development, you can use the shop.o'reilly.com product. There are GitHub has very good examples like Red Squirrel Take, and also for secure smart contracts you can use Open Javelin contracts. So Open Javelin is very good here. They have codes for all tokens. So these three website is very handy. So I can quickly walk through Remix. We have see how it is designed. If you go to other like a fundraiser kind of smart contract, it looks like there which I am showing you. So it has a constructor means fundraiser who can anybody can donate or my donation function. So it looks very simple. Simply you can rules protocols so you can document here. The similarly you can use truthful boxes. So truthful boxes, if you go to this side, it you have lots of small simple codes for blockchain basics. You can go to docs.solidity to understand solidity language. The open javelin we have listed here, which is very good for secure smart contract development. From GitHub, you have Red Squirrel Tech, and this has some example for fundraiser. That's good. And okay, so that's all from my side. Any questions now?
Thank you, Bhavani, for your presentation. And we did have one question in the beginning, and it was about, isn't the blockchain the third person in this case? Is the blockchain always trustful then? That was about fourth or fifth slides. Do you see the question on the screen?
Uh, yeah, I was. Yeah, blockchain is always trustful. So here there is no any third party or anyone can tamper it. So this is 100% trustful. And blockchain the third person in this case. So yeah, there can be multiple buyer like between buyer and seller. There can be multiple persons, and no third party means who takes commission or some percentage for the transaction. So there is not that. So only those can transact who is using who are the parties in the contract. So like renting a house. So if you renting a house, there is a tenant and there is a owner. So owner, if created a smart contract, may it create for open a smart contract, then tenant can be any thousands of people, and those who accept the rules, terms and conditions, and pay that amount, uh, that transaction happens. So similarly, so there can be many buyers, but once first person who do the transaction, that becomes the main party.
Okay, I think that was the only question I see in the YouTube live chat. And thank you, Bhavani, once again for your great presentation. And we will publish the recording on our YouTube channel. So please subscribe to our social media channels to stay tuned. And I hope to see you next time on March 15th. We will be having Joe Anugo, Senior Manager at EPAM USA, who will be speaking about decentralized voting. So thank you once again for coming. Thank you, Bhavani, and see you
Yeah,
soon.
thank you all.
Bye bye.
Bye.